Hello. This will be a demonstration of proposition 16 from book 10 of Euclid's Elements, which says that if two incommensurable magnitudes be added together, then the whole is incommensurable with each of them. But if, on the other hand, the whole is incommensurable with one of them, is incommensurable with one of its parts, then that part and the other part will likewise be incommensurable. On the one hand, we're given two magnitudes AB and BC, and they will be incommensurable with each other. And we'll want to prove from that if we add AB and BC together to get the whole AC, that whole AC is incommensurable with both AB and BC. But if, on the other hand, we're given that AC is incommensurable with one of its parts, say AB, then we'll want to prove that part AB is incommensurable with the other part, BC. So first, we'll start out with AB and BC being incommensurable, from which we'll want to prove that AC is incommensurable with both AB and BC. For if it is not incommensurable with one of them, say AB, if AC and AB are commensurable, then there will be some magnitude D which measures both of them. So we'll set out a magnitude D which measures both AC and AB. If they're commensurable, this will of course be possible. But since D measures both AC and AB, D will also measure AC minus AB. That's a property of magnitudes. So D will measure AC minus AB. But AC minus AB is just BC, so D will measure BC. But D was also contrived to measure AB. So it's a common measure for both AB and BC. D measures both AB and BC, which means AB and BC are commensurable. But this is contrary to what we were given. We were given that AB and BC are incommensurable. And so we have that two magnitudes are both incommensurable and commensurable at the same time, which is absurd, from which we can conclude that AC is incommensurable with AB. Now, in a similar way, we can likewise demonstrate that AC is incommensurable with BC, so that the whole AC is incommensurable with each of its parts, AB and BC. But if, on the other hand, we're given that AC is incommensurable with AB, then we'll want to prove that AB and BC are incommensurable. For if they're not incommensurable, if they are commensurable, then there will be some magnitude, let's call it again D, which measures both of them. So we'll set out a magnitude D, which measures both AB and BC. If AB and BC are commensurable, this will of course be possible. So D measures both AB and BC. But if since D measures both AB and BC, it will also measure AB plus BC. That's another property of magnitudes. So D measures AB plus BC. But AB plus BC is just AC, so D measures AC. But it was also set out to measure AB, and so D again is a common measure of both AC and AB. But since it's a common measure, it means that AC and AB are commensurable, which is again contrary to what we were given. We were given that AC and AB are incommensurable. So we have that two magnitudes AC and AB are at the same time incommensurable and commensurable, which is impossible. So we conclude that AB and BC are incommensurable. And this being all that we set out to prove, we are done with the proposition. Therefore, etc. QED. That's all I've got to say about this proposition, so I'll end the video here and move on to proposition 1017.